solutions, mixtures, those darn chemistry things.
They are not just in, well, I guess it's mostly chemical things, but like alloys, where you have
I don't even know what you just said just now.
gold
So
mixed with something else. Anytime you have a percentage of something, you typically have something like this. This is the case where you have two things you're putting together into one thing. The important thing to realize is that if you got a percent times an amount plus a percent times an amount, it equals a percent times an amount.
Right.
And
the unit has to stay the same the whole way through.
Right.
That's the important thing.
So, on this example, Ted wants to make 10 liters of a 29% saline solution by mixing together a 15% saline solution and an 85% saline solution. So how much of each must he use? We want to make basically this formula.
We know that he wants 10 liters of 29%. So that's on the right-hand side of the equal sign.
Indeed. Now, we don't know either of these two amounts, but we do know that they have to add up to be 10.
Right.
So one of the amounts we could call x.
And the other amount we could call 10 minus x.
Right.
And it doesn't matter which one's which.
Right. Either way, we'll end up being able to figure out both of them.
Right.
And there are a couple other ways you could do this. The way we're doing this is helping us to avoid a system of equations.
Right. Right.
Just because we haven't talked about that yet, and we won't really talk about systems for a while. But this is, if you can do this, these two things, x plus 10 minus x, that should add up to be 10.
Right.
And then
well, and if you're a whiz bang with a system already, and
then
you're
by
like
all means.
if you're a chemistry nerd and this is old info to you, by all means, as long as the math is correct, we don't care how you do it. But math
needs to happen.
Math needs to happen correctly. So
I'm just sitting here distributing.
Math. Can't create math.
Things do not just randomly come out of nowhere.
Right.
Oh, I can do this. 0.29 times 10 is 2.9.
2.9 there, Mrs. K. Steve.
Okay, I distributed on this right here and multiplied that out. Now we want our x's together and our numbers together. 0.15x minus 0.85x.
I believe that's negative 0.7.
Yep. And let's subtract 8.5.
Oh, that's a little trickier. Negative 5.6. Now, here's where you'll know if you've set it up correctly or not.
Because when we divide, both negatives.
They're both negative. So if you wind up with one positive, one negative, we're not going to add a negative amount of solution.
Because you can't.
Can't do that. So no.
So this looks like a 8 to me.
I believe it is an 8.
So we will have 8 liters.
Yes.
Of the 15%.
And why do we know it's 15%? Because that's where the X is. And that means we're going to have 2 liters of the 85%.
And this is the way we would want you to write that out, to actually specify. It doesn't really, it's not super helpful for you to say, oh, 8.
Yeah, 8. I got 8.
I got 8.
Hey, me too.
Did you get 8?
I got 8.
I got 8. We got 8.
I got 8 17 times.
But it's better if you tell us 8 of what.
Right.
And then what is the other thing? 2 of that.
Right. So. We need all the info.
Now,
oh yeah, we can.
Code word for this video is going to be, it's all the way back from the first example where we said minus hashtag oops. If you'll just type that in on the assignment on Edmodo, that's our code word for section 1.7.
This is beneficial.
Code words are good. Put that in. Don't tell your friends. Let them find it for themselves.
That's right.